Imagine that. Some red thorn and poor landscapes on Mars, transformed into a green garden, became a free flow. Carve a canyon, the planet that shapes lakes and oceans. Can we rely solely on pour water into the earth to realize this fantasy? Before you rush to deny, why don't you join me in exploring this camera in depth? If we could somehow magically transferring all the water on Earth to Mars, this will be an outstanding opportunity in engineering and logistics. Crazy challenge. The first challenge we face is millions of cubic meters of water were removed from the Earth. This requires a very large container. Next, we have to find a way. Launch these giant water containers into space. That's absolutely true. The ultimate test of rocket technology and large amounts of fuel. We may need to build a fleet of spacecraft specifically designed for this mission. Imagine that. Pair giant space flags laden with carefully collected water sources, launched from Earth. How spectacular it will be to travel through space. Another approach that may be more feasible is, as time goes by, launch a large number of small missions. Each mission requires less water to transport enough water to Mars. Suppose we overcome all these challenges and successfully reached Mars. Next step. What we need to do is distribute that water to Mars. Surface, we can use underground pipes, network, or custom drone. Send the water to different places. As you can see, this requires tremendous planning and resources. Such a crazy project requires scientists from all over the world, engineer, and close cooperation and coordination among space agencies. But even if we solve all these problems, pour Earth's water into Mars, the results can be frustrating. Mars is a dry desert world. Its atmosphere is only about 1% as thick as Earth's. This means that any moisture, almost all evaporate rapidly. The temperature on the surface of Mars is well below freezing. The thin atmosphere will only exacerbate evaporation or freezing of water. The magnetic field of Mars is very weak, hardly able to withstand the sun's peak. These streams of charged particles can be easily carried away. Any moisture on the surface of Mars. The intensity of solar radiation on Mars is also much higher than that on Earth, makes it more difficult to maintain liquid water. And we also need to purify this water to get rid of all bacteria, ensure their appetite for drinking. Despite this, if we stay optimistic, it is still possible to try to solve these problems. Basically, we need to find a way to make it last longer. Keep the water liquid. Make sure it neither freezes nor evaporates. One way is to use insulation, such as foam or reflective materials. Wrap the water-soluble gas. Helps prevent water from freezing. In addition, we can also use heaters and other equipment. Keep the water temperature above freezing. Although this will consume a lot of energy, and it's a tall order. In addition, we can also consider building underground reservoirs. Dig large holes and cover them with transparent materials. Using sunlight to maintain water temperature. Simultaneous insulation by adding a small amount of salt to the water or other dissolved minerals can reduce the freezing point of water, although this is important for the construction of the lake. Waiting for large bodies of water is not the most efficient approach. And finally, build greenhouses or other structures that can absorb heat and create a structure that is closer to the Earth's environment. May be the best choice. After all, when chambers could not only help us grow plants on Mars, plant various plants, it can also support other forms of life. Imagine we've found a way. Storing water on Mars, and manages to keep it lukewarm in its liquid state. What impact will this have on Mars? Actually, this will be an exciting transition. If we could pour massive amounts of water on Mars, could dramatically alter this cold red. The climate of a colorful desert planet. We can first create what is called temperature chamber effect. That's gases in a planet's atmosphere trapping heat, causing planetary temperatures to rise, although this is a problem for the Earth. But for Mars, its temperature fluctuates between -60 and 120 degrees Celsius. The introduction of the greenhouse effect will be very significant. This could make the atmosphere thicker and could cause the polar ice caps to melt. Imagine that. Mars is gradually becoming a new Earth 2.0. Not only does the atmosphere change, weather patterns can also form. For example, there is cloud river rainfall. This is useful for irrigation of plants. That would be a huge step forward. However, all of these ideas are still in the hypothetical stage. We can't be entirely sure about introducing water to Mars. The surface will affect its climate. What exact impact? Although there may be a greenhouse effect, but the amount of water we need is far more than we can transport. Even if we overcome all challenges, successfully made Mars warmer and wetter. Whether life can be born, there remains to be seen, although water is essential for life. But not all life needs. The composition of Mars soil is not conducive to supporting life, mainly composed of dust that is unfavorable to plants, sand and other minerals. We could, in theory, try to terraform Mars, but it's going to be an incredibly complicated task, a long and costly process. And considering the cost of transferring large amounts of water from the Earth, this kind of action, perhaps on our own planet, have adverse effects, especially in regions where water resources are already scarce. From any point of view, this was not a practical plan. He needs too many resources and funds, and it may not be cost-effective at all. This is why scientists and space agencies, it is not considered as a practical agenda to consider. Instead, focus on more realistic and palatable goals, such as studying the geology of Mars' atmosphere and the potential to explore past or present life.